Your Telegram works fine. Then a channel won't open. Then a group is gone. Then it comes back next week like nothing happened. Indonesia doesn't switch Telegram off with one clean kill switch. Cominfo issues orders that move faster than you can adapt to, and your clean connection dies while everyone already on a VPN keeps going. This is the setup that survives the next order built on hardware that doesn't live in Indonesia at all. I run a managed Telegram hosting setup. Real Android phones in Singapore. Real Singapore SIM cards. Real carrier IP addresses. I watched this block cycle from the outside, and Indonesia is one of the messier ones we deal with. The pattern goes back to July 2017, when Cominfo issued its first major block order because Telegram was slow to remove extremist content from public channels. That block lasted about a week. Pavel Durov agreed to designate a moderation contact, the flagged channels came down, the ISPs lifted it, and the cycle started. This is for anyone in Jakarta, Surabaya, Medan, or anywhere else in Indonesia running channels, communities, or business operations on Telegram who needs the account to stay online through the next enforcement cycle. By the end, you'll understand why your VPN keeps dying, what actually survives ranked by survival rate, and how a session that lives on Singapore hardware sidesteps the whole problem. Here's the plan. First, how the Indonesian block cycle actually works and why it's gotten harder. Then the 3 technical walls that kill your VPN. Then what still works, from weakest to strongest, plus the account safety details that catch people moving in from a +62 number. Start with the cycle, because the shape of it explains everything else. Cominfo receives complaints from the cyber agency, from the National Police Cybercrime Unit, from political pressure during election seasons. It issues a takedown demand with a compliance window of 24 to 72 hours. If Telegram's trust and safety team doesn't respond fast enough, the major ISPs get instructed to block. IndiHome from Telkom, 40 Axiata, Indosat Ooredoo Hutchison, and SmartFriend all implement at DNS and IP level within hours. The app still works for anyone already tunneled. Clean connections die. The enforcement has matured. Cominfo's network monitoring runs deeper packet inspection at multiple internet exchange handoff points now, and the Content Moderation Directorate has more staff than it used to. This isn't a think tank's guess. ONE runs passive network measurement from thousands of test points inside Indonesia, and their longitudinal data shows a steady climb in blocking events over the past 5 years, with Telegram appearing repeatedly in confirmed block lists. The cycle accelerated around the 2024 general election, and again during the parliamentary fights over the revised Electronic Information Law. By 2026, the pattern isn't new, it's just more frequent and more technical. Now the 3 walls. The first is deep packet inspection. Telkom's core routers and the other major carriers run DPI equipment that fingerprints VPN protocols by traffic pattern even when the payload itself is encrypted. OpenVPN's handshake has a recognizable byte sequence. WireGuard's EDP behavior stands out. There are public procurement records showing DPI hardware from vendors including Huawei in prior tender cycles. The short version is that your VPN's protocol signature gets flagged, and then the IP lands on a block table within days of becoming widely used. The second wall is the known IP block list. Commercial VPN providers recycle their server IPs. A Singapore or Amsterdam server shared by tens of thousands of Indonesian users gets flagged faster than you can rotate off it. The IP lands on Cominfo's list, the ISPs pull the update and apply it, and you reconnect to a new IP from the same subnet which is also blocked. The loop of connecting to a different server isn't a solution, it's a countdown. The third wall catches the people who think HTTPS protects them. When your device opens a TELNET connection, the server name indication field in the first packet reveals the hostname you're reaching before encryption kicks in. Indonesian ISPs inspect that SNI field and block specific hostnames even over port 443. Telegram's CDN domains and API endpoints are on those lists. Obfuscation proxies that tunnel through an innocent-looking hostname can work in theory. In practice, the effective ones get discovered and blocked within weeks, and the config is fiddly enough that most people never get them stable. So what actually works? Let me rank these by survival rate. At the bottom of the ladder that's still worth using are mtproto proxies built into Telegram itself. Telegram's native mtproto protocol was designed with censorship in mind. You enter a proxy server address directly in Telegram settings under data and storage, and it speaks Telegram's own protocol, which makes it harder to block than a generic VPN. The problem is the discovery cycle. Proxy lists circulate in public Telegram channels, and call Minfo monitors those same channels to harvest fresh IPs to block. A new mtproto address survives days to a few weeks before it lands on the table. For one personal account, that maintenance is tolerable. For 10 business accounts running different sessions, you're rotating proxies continuously and losing conversations every time one dies mid-thread. That doesn't scale, and it's exactly the wrong kind of fragility when the account is a business dependency. Up a rung is a mobile SOCKS 5 router to a neutral jurisdiction. A SOCKS 5 proxy running on a real mobile IP in Singapore or Japan performs dramatically better than a data center VPN. Real carrier ranges from operators like Singtel, M1, and StarHub aren't on Kominfo's block lists because blocking them would cause collateral damage. Indonesian e-commerce platforms, banking apps, and enterprise software all call Singapore-hosted endpoints. Blocking Singapore carrier ranges would break legitimate commercial traffic in ways the ministry can't afford politically. That asymmetry is what makes mobile carrier IPs durable. The catch is finding a legitimate source, and you have to verify it. Data center IPs sold as Singapore residential are everywhere in this market, and they fail exactly when you need them. You run your endpoint through a geolocation check and read the org field. The org field should show a real carrier. Singtel, M1, StarHub, Vivifi. Not Google, not Amazon, not DigitalOcean. The country should be SG. If org comes back as a cloud provider, you have a data center IP, and the block resistance you're counting on isn't there. This one check has saved a fair number of our customers from paying for a proxy that would have died in the next cycle. At the top of the ladder is a full managed cloud phone, and this is the structurally different bet. Instead of routing your local traffic through a proxy, the Telegram session itself runs on a physical Android device in Singapore, on a real SIM card with a real Singapore carrier IP. Your local internet drops, the session keeps running. Kominfo issues a block order in Jakarta, nothing changes on the Singapore side because the phone isn't in Indonesia. You're not tunneling Indonesian traffic out to a foreign endpoint, you're reaching a phone that already lives in Singapore through a browser from wherever you happen to be. Highest survival rate, highest upfront cost, worth it when continuity is the whole point. The reason Singapore specifically holds is structural, not a marketing line. Censors block what they can block without paying a price. Indonesia and Singapore are bound by a free trade agreement with heavy investment flows across banking, logistics, and technology. Indonesian regulators blocking Singtel or M1 ranges would generate formal complaints from Singapore's monetary authority, from Indonesian companies that run on Singapore cloud infrastructure, and from the regional tech press. The cost is too high, so those ranges stay clean. That's not a permanent guarantee, nothing is, but it has held through every Telegram block cycle on record, and it's structurally more durable than data center proxy apps which carry no diplomatic protection and get burned routinely. Be honest about latency. Connecting from Jakarta to a phone in Singapore adds 60 to 90 milliseconds of round trip to every interaction with the interface. From Surabaya or Medan, add another 10 to 20. For casual use, you won't notice. For high-volume account management, sending hundreds of messages an hour, it's real and occasionally annoying, not unusable. It's the price of a session that stays online through blocks, through power cuts to your local router, through whatever Kominfo does that week. Most operators who've lived through one serious block period consider that a fair trade. The login is simpler than people expect. You connect to your assigned device through a browser session, open Telegram on the remote Android, enter your own phone number, and the one-time code arrives on your own local device. You type it in, we never see your credentials or your code. After that first authentication, the session persists on the hardware in Singapore, and you reach it from Indonesia through the browser whenever you need it, nothing to install locally. Here's the account safety detail that catches people. Phone number country code matters more than most operators realize. An Indonesian +62 number that suddenly starts authenticating from a Singapore carrier IP can trip Telegram's own anomaly detection before Cominfo is even relevant. Telegram logs the country of the connecting IP and a session that always came from telecom cell ranges and then jumps to a Singapore range looks like a SIM swap or a takeover. You may get asked to verify again. Friction, not disaster, but avoidable. The clean path depends on your situation. If you're setting up a new account for business, register it on a Singapore plus 65 number from the start. A plus 65 number on a Singapore phone connecting from a Singapore IP is internally consistent and Telegram sees nothing unusual. If you're moving an existing plus 62 account onto the cloud phone, do it gradually. Keep your local session active for the first week while you also connect from the cloud phone. Let Telegram see both sessions coexist, then let the local one expire naturally. Two-step verification is not optional, and you enable it before you move the session anywhere. Without it, anyone who gets your one-time code owns the account. The detail that matters is that the two-step password is separate from the code and is checked after the code succeeds. Both have to be correct. That's the minimum baseline for any account you actually care about, and it's free. For one more safety point, Contact Sync deserves attention on cloud phones. Telegram's Contact Sync reads the local address book and links your account to every number stored there. On a cloud phone with an empty address book, this is a non-issue. On a local device you also use for personal life, turning Sync on creates metadata linking your business account to your personal contacts. Keep them separate by design. Run the business session on the cloud phone, the personal account on your own device, and don't let them touch. If your business depends on Telegram staying online through Indonesia's block cycle, this is exactly what we built Telegram Vault for. Manage Telegram hosting on real Singapore hardware, a physical Android phone, a real Singapore SIM, a real carrier IP that sits outside the Indonesian enforcement perimeter. Your existing number stays yours. The session keeps running when your local connection drops and you reach it through a browser from anywhere. Pricing runs $99 a month for one account, scaling to $899 a month for 15. Card and crypto both work from Indonesia without a foreign issued card, and stablecoin is a clean option given the local fintech uncertainty. The current phase is a concierge pilot, so onboarding starts with a short setup call rather than a faceless sign-up form, and we usually respond within one business day. Join the waitlist at telegramvault.org and use code TGYT for 30% off your first month. One honest caveat. If Indonesian regulators ever specifically targeted the Singapore carrier ranges in our farm, the architecture would need adapting. We monitor for that actively. It hasn't happened, and the structural reasons it's unlikely are the ones I just walked through. You should know the dependency exists. Subscribe if this helped because I'm working through the whole region one country at a time. Next up is Saudi Arabia, where the void block is enforced by 3 carriers and BPI together. Different country, different mechanism, same Singapore cloud phone fix at the end of it. I'll see you in that one.